Hi, this is Miss Fitzmaurice, and this is video about pulleys. Okay, so by the end of this video, you should be able to draw force body diagrams with pulleys, okay, and also use Newton's second law with pulleys. Okay, so let's take a second to look at this situation. Imagine you have a pulley. So that's just a little thing that's you can thread a rope through. It spins around. Excuse me. I'm getting sick. And you have these two objects hanging from a rope. Now you're probably thinking, okay, the 5 kilogram one is going to go down. The 2 kilogram one weighs less. It's going to move upwards. But what if we wanted to find the acceleration? How could we do that? Okay, and the answer is, as the title suggests, pulleys are magical. And what I mean by that is when you're drawing a force body diagram with a pulley, you can kind of take the individual objects, draw the forces on them, and then unwrap, and this seems like a really weird thing to say, but you can unwrap the forces in the force body diagram. So I'm going to show you what I mean. Okay, so I have the same situation. Okay, I have a pulley, I have 2 kilograms and 5 kilograms. I'm just going to write 5 and 2. And I want to know, first of all, what is my acceleration? And second of all, what's the tension in the rope that's holding them? Okay, so what I want you to do is I want you to draw this, and I want you to take a minute and just on the individual objects, try to draw the forces that are acting on these objects. Okay, so you've gone ahead and you've drawn the forces acting on the objects. You know that there's tension pulling up on both of these, and that there's FG, I'm going to say this is FG2 and FG5. Okay, now I want you to think back to the video about multiple objects and tell me which of these forces are internal and which are external. Okay, so these two tension forces, they are between the two objects, so they are internal, and both of my FGs are external forces. Okay, so you might be thinking, okay, that's a weird force body diagram. I have FG5 going down and FG2 going down, but they're not both falling down, so how does this work out? Okay, this is the wrong force body diagram. What you're going to do is you're going to take only the external forces, okay? And what you can do for a pulley is, because it is magical, you can unwrap the force body diagram. So I'm going to take this FG2 and bring it up so the string's straight. Okay, if I read through that, these are the forces that I would have. I would have FG5, and then I unwrapped the pulley so that FG2 is pointing straight up. And that's actually going to be my force body diagram. I have FG2 up and FG5 down. Okay, I just straightened out the string. Now, there are a couple ways that I could straighten out the string, and they'd all be right. So I could have FG5 to the left and FG2 to the right. Okay, I could have FG5 up and FG2 down, these would all be force body diagrams. That would be fine. Okay. They would all get me the same final answer. So I'm going to erase these two, and I'm going to use them to build a Newton's second law equation. Remember that this is something with a system, so I have sigma F system, and I'm going to say this is in the y direction, is equal to m system a y. Okay, so I want you to take a minute and try to write out Newton's second law. So fill in the up minus down, try to plug in the masses, try to solve for acceleration. Okay, so in this case, I have Fg2 up minus Fg5 down is equal to the mass of my system, which is 2 plus 5, times A. Okay, Fg2 is going to be 2 times 10 minus 5 times 10, okay, because these are mg, is equal to 9a. Oops, 2 plus 5. So it is 7a, not 9a, because I can't add. So 7a, that's just because I'm adding up these two masses, 2 and 5. Okay, so I have 20 minus 50, negative 30 is equal to 7a, and my acceleration is negative 30 divided by 7, whatever that is, meters per second squared. Okay, now if I want to find the tension, remember that tension is an internal force. So I want you to pick one of these two things, draw a force body diagram, and then find me the tension. Okay, and then I'll go over the answer in a minute. Okay, so I'm going to pick the 5 kilogram mass. These are the forces acting on it. Okay, so by the way, I'm finding T. Okay, so I have Fg5, and we know that's 50 because it's m times g, and I have tension. So here's my sigma Fy. Sigma Fy equals m-a-y. Okay, I know that T minus 50 is equal to my mass, which is 5, times my acceleration, which is negative 30 divided by 7. Okay, and I can solve for tension. I find that T is equal to 71.4 newtons. Alright, so I have one more for you to try. Imagine that there is instead a block, a pulley, and another block. Okay, for simplicity, let's say no friction. Okay, this block is 2 kilograms, and this block is 1 kilogram. I want you to first draw FBD of the system, the force body diagram of the system, and 2, find acceleration. Okay, so take a minute and try to do that. Alright, so now that you've taken a minute, let's go over the external forces acting on this system. Okay, on our 2 kilogram, we have Fg, okay, and we know that's m times g, if it's 2 times 10, and that's 20 newtons. Okay, on the 1 kilogram object, we have Fg, We know that is 1 kilogram times 10, which is just 10 newtons, and we have Fn going upwards. Now you might be tempted to draw this tension force. Don't do that. It's an internal force, so you're not going to put it on your force body diagram of the system. Okay? There are actually no other external forces. So if I unwrap the string, what I see, okay, I'm going to bring the mg up this way. I'm going to see I have a Fg going down. I have a different Fg, I know that's 20, going to the side because I've unwrapped the string to make it straight. And I have Fn going upwards. Okay, obviously in this case, Fn is equal to Fg, 10. And so if I'm writing out the acceleration, I have sigma Fx equals max. Now this might seem weird because one of the things is going to the side and one is going down, but in my total force body diagram, that's my x direction. Okay, so I only have the 20 newtons going to the right, and that's equal to the mass of my system, which is 1 plus 2 is 3 times A. Okay, and if I solve for A, I end up with 16.7 meters per second squared. Okay, so I hope this has given you a good sort of initial understanding of how to deal with pulley problems. We will practice many of them in the coming week.